reset the camera. It's like every time the computer restarts, the camera doesn't get recognized. And that's a brand spanking new. Okay, so, oh yeah, baby. Okay. So, our first one that we're going to do is the integral of sine squared. Okay? Seems kind of benign. Seems like, oh, that's not a big deal. But actually, it's a little tougher than it looks. Okay? There are actually two ways to do this. And we may end up doing it both ways, but I'm going to do it one way first, and then if there's time, we'll come back and do it the other way. Okay, the first way that we're going to do it is not by parts. Okay, we're going to use the trig identity. Okay? So up in the left corner of the board, you see those 4 things written down there. Those are known as the double angle identities from pre-calc. Okay? Sine of 2x or sine of 2 theta is 2 sine theta cosine theta. Does that ring a bell? I mean, you've seen it. You definitely have seen it. Okay? Then cosine of 2x or cosine of 2 theta actually equals 3 different things. It's cosine squared minus sine squared, 1 minus 2 sine squared, and 2 cosine squared minus 1. That equals 3 different things. Those identities come from the sum difference identities. You can see that?
No.
Okay? Those identities come from the sum difference identities. And the sum difference identities are the ones that go sine, cosine, cosine, sine, cosine, cosine. Yeah, so you've seen that before. All right, so what I'm going to do is I'm going to think about sine squared a little differently. Because 1 minus 2 sine squared equals cosine of 2x. So solve that for sine squared. What do you get when you solve this right here for sine squared? What do you get when you solve this one right here for sine squared? Well, I mean, do we need to work it out here? So we get 2 sine squared x equals 1 minus cosine of 2x, right? So sine squared is 1/2 times 1 minus cosine of 2x. Or, if you want to distribute the 1/2, like that. So now, what is sine squared then? If we replace that in our integral, what is it going to look like? Sine squared is equal to 1/2 times 1 minus cosine of 2x. Now, why is that helpful? Why is that helpful to us? Well, we got rid of the square. And I have an integral there that's actually pretty doable. Okay, so you want to take the 1/2 out. Take the 1/2 out, and then you get 1 minus cosine of 2x dx. So what is that? What's the antiderivative of 1? X. What's the antiderivative of cosine of 2x? Can we do that in our head? The antiderivative of cosine is negative sine, positive sine, right? You always want to probably think through those. So the antiderivative of cosine of 2x is going to be sine of 2x over 2 plus 2. Okay? Now, just out of curiosity, if I asked you to put this back in terms of 1x, not 2x, what would you do? You would use this up here. Sine of 2x is 2 sine of x cosine of x, so this is equivalent to this. Right? Because of sine of 2x equals 2 sine x cosine x. Now, of course, I can cancel those 2's. That can already cancel. How would you do cosine squared? If we had to do cosine squared, what would we do? It is 1 minus sine squared. So you could do cosine squared by rewriting that as 1 minus sine squared, right? And you now know the antiderivative of sine squared is this. There's another, and I didn't think about that, Megan. That's not how I was thinking. When I asked that question, I wasn't thinking you were going to say that as your answer. But that works. Another way to do cosine squared would be to take this identity, cosine of 2x, and instead of solving that for sine squared, solve it for cosine squared. And it's almost going to be exactly like this. Okay? Questions on that? All right, let's try another. How about this one? The integral of secant cubed tangent cubed. Secant cubed, tangent cubed. Now these guys go together, right? These guys go together like these and here. Because the derivative of tangent is what? Secant squared. And the derivative of secant is what? Secant x tangent. Now, I can't use that right now because I have too many. Like, for example, I can't let u equal tangent. Why not? If I'm going to try to do this by a substitution, not by parts, okay? If I'm going to try to do this by a substitution, I can't let u equal tangent. Why? What's du? It's secant squared. What's the problem with that? I don't have secant squared. I got secant cubed. I got an extra secant. What do? Okay? Can't do that. I can't let u equal secant necessarily because the derivative of secant is secant tangent, right? And I got tangent cubed, right? But isn't there a relationship between secant squared and tangent squared? What is it, Ross? Oh, you were disagreeing with me? It's the best. 1 plus tangent squared equals secant squared. Okay, guys, if we don't know those identities, like if we don't have those kind of in our pockets, we got to get those in our pockets. Okay. So watch this. I'm going to call this secant of x times secant squared. And I'm going to call this tangent squared x times tangent of x. Okay? And then I'm going to say secant squared, tangent squared, secant x, tangent x. Did that do anything for you? What do I want to do now? What's hanging out on the end? What do we have hanging out on the end there? Secant x tangent x, which happens to be what? The derivative of secant. So can I put that all in terms of secant, and then that can be my du? Can you put this all in terms of secant? What's tangent squared in terms of secant? Secant squared minus 1. Oh. So now I can do this with a u sub. U is secant of x. U is secant x tangent x. So this is u squared times u squared minus 1 du. Very similar to the one we had yesterday, isn't it? So what's our next step there? Distribute. So that's u to the full minus u squared du. U to the 5 over 5 antiderivative. U cubed over 3. So go back and resub.
So you can't do u to the 4th minus u squared. You do u to the 4th minus u squared before you improvise.
You can't do what?
You can't just you can't make it u squared du.
Right here?
For that. U squared. You have to keep doing u to the 4th minus u squared. Because x to the 4th minus x squared is x squared.
No, it's not.
Yeah.
I'm glad you said that, because I don't know that I was going to catch what you were saying. Yeah, u to the 4th minus u squared algebraically doesn't equal u squared. Doesn't it? Yeah. You weren't wearing your algebra pants.
No, I got it.
Yeah. Quick change. Okay, questions on that? So we gotta like these identities, man. Oh, who doesn't love the trig identities? Don't you guys remember in trig, did you do trig proofs, like identity proofs? This is one of the reasons why you did that. You didn't do that during quarantine, did you? Like during the shutdown? That was right before. Yeah, that's about what I would guess. It would have been right before. What did you do during shutdown? Did you do polar? Yeah. All right, let's do another one. Anybody have an idea?
Separate it into sine squared and sine x.
Okay, so let's do that. See what happens. Now what do we do? Change sine squared to 1 minus cosine squared? Oh, look at that. And now I got a du hanging on the end. So when you're doing these and you're doing them with substitution, that's sort of the goal, is to get something that is going to serve as your du. Does that sign work as a du? Yeah, because what's u? Cosine. So that u is cosine, then what's du? Negative sign? Negative. Negative negative. So that's 1 minus u squared du. And what's the antiderivative of 1 minus u squared? Not x. Plus the cheeks. I'll go back and sub in. All like that. That was fun. It's just so satisfying when they come out perfect like that. Now the struggle is real. Like I can't show you an example of every single one of these that you'll ever do. Like some of this is a strategy thing. Like you gotta try stuff and be like, oh yeah, that works, that doesn't work. You use similar strategies on previous problems. You know, like for example, this one with secant and tangent. Okay? This one with secant and tangent. The goal here was to get this all in terms of one trig function. In fact, that's always the goal. Essentially, is to get it in terms of one trig function and then have a du on the end. Okay? That's what we did here. I mean, yeah, you're saying, well, it was in terms of one trig function. But the problem is you need to have a du on the end. If you're going to do it by substitution, you got to have a du. All right? Real quickly, I told you we'd go back and circle back and do sine squared. I at least want to show you how it looks. We did this in fourth period the other day. But probably you can watch the video of it. But I'm pretty sure we did it in fourth period. Maybe not. So if you want to do it a different way, you would do it by parts. And that's how you set it up. Now the bell's about to ring, so I won't be able to finish it. But I will tell you this. If you do this by parts and you set it up that way, this ends up being one where the integral of sine squared will reappear in the problem. Okay? It's going to happen right here. uv minus the integral of v du. Okay, and that's going to end up being plus. You don't do it by parts again. You change him to 1 minus sine squared. Okay. So I put some problems on Classroom for you to try for the weekend. So, I mean, we just are going to be integrating until we grow up. Integrating all day, every day. We love integrating. You do? Are those Doc Martens you're wearing, Annie? So Becca, my younger daughter, she showed me this thing that what did you do with it? You could sell that.
Well, I was thinking about it, but there's no copyright thing.
Yeah, that's true. Right. I mean, like, if I had little girls, I would have bought that. I would pay you like lots of money.
Yeah, I did have a lot of
like, how long did it take you to do that?
well, I kept taking breaks.
Right. I mean, the video makes Oh wait, I didn't spray. Here, let's watch this. This is when he sprays. Isn't that cool?
Oh, yeah.
Yeah, I stole this idea from her. Well, actually, how you stole it from her.
Yeah, I was.
This is the coolest thing in the world. Are you all smooth? Smooth? Oh, I felt Adele's legs. They're smooth. Great. Don't worry. I think Billy, are you all smooth? Yeah. Oh, nice. I think. Jimmy, are you smooth? You didn't shave up? Really? Go up. No. Yeah, you didn't know. What the heck? Yeah. There's nothing. I'm smooth as a vivid. Do we have to take this back then? The quiz?
I mean, I think it's pretty much just a double.
Yeah.
I mean, you don't
Getting the news. Yeah. I only did like
like the first part, I didn't just like, it was literally the exact.
Wait, it's a
The
quiz,
part
right?
two,
Yeah.
the part two was
Part two is
it was just, okay, I did the first one and then, yeah, the other three were.
Is it unity
And
minus the derivative of BDU?
Yeah.
Yeah, got it. Good. What is that integral?
But that's
That's what I meant, Billy. I really spent all that time studying. I'm excited to see if these grades are tested.
you know,
I'm assuming I have that, but I want her to try to see how I did good or bad. I either did really good or I did really bad. Like, there's not gonna be. Oh, yeah, I think. Actually.
The building that's how many, yeah, and the people are much harder, the people with, like, in the last 3 years. Oh, wow.
Okay, problem four, is it gonna be like that or no?
I don't think so. But I don't.
Coach Mitter, yo, you want to feel my leg?
What? Did you shave?
Yes.
Oh my god.
Just feel my leg.
You'll have my sister next year.
I know. Yeah, that's what your dad told me. Because I just said, oh, Carrie's great. I'm not sure what that means. That was so much.
See? No, Mackenzie is.
I don't know, you're all great. Billy, get behind me. I know if I can help Jack the process. I have a very special test. muchachos? Well, let's take a little quiz. I gotta email this to the other folks at home. No. Doesn't hurt to ask though. Can I use my notes? No. There's only 4? 4? Yeah. I don't want to do this all day. Oh, yeah, good. Okay, so I forgot to give you a bonus question last time. So I'll give you a bonus question. If you're watching at home online right now, we're taking the quiz, which I'm going to email you in about 5 minutes. So your bonus question is just random trivial knowledge. That's nothing good than that. If you know the answer, put it underneath your name. Free, bonus point. I'll give you last period. There's only one person got right. Okay? I think your question is going to be actually a little easier. So last period's question was, in the game of Monopoly, there are 4 railroads. There's the B&O, the Pennsylvania, the Reading. What's the 4th? That was last period. Anybody know the answer to that? No? Short line. Okay, your question is, I'm going to give you the name of a person in the United States that's famous. Okay, I'm going to give you a person who's famous. You tell me why they're famous, what makes them famous. Okay, you ready? Here's the person. John Roberts. John Roberts. Who is that? Why are they famous in the United States? It is a pretty basic name, but this person has a pretty not so basic job. We're also currently on YouTube Live, so don't swear. Bless you. Oh, and you can use Rapido if you want. I forgot to tell you that. There's a couple of these that are nice to use Rapido. 09. Oh, lordy, lordy. Jen? John Roberts.
I don't know.
Robert? Robert. Like Roberto, but Robert. No, he's not really. It's got a pretty important job. I think he did that before he got this job. Are you finished? Let's go, man. Well, you can. I'm fine. I think you're good. Yeah. I don't want to rush you. You didn't even guess?
I don't.
Give me something creative.
Okay. It's something random.
John Roberts.
I look him up right now.
I just want more fun.
What his dog is?
Wait, is he like a homie? No. Either no or not. It's either. Well, Jimmy knew immediately. As soon as I said it, I saw Jimmy write it down immediately. Yep. He's not like TikTok famous.
That makes sense.
5 more minutes. Or 4.5. And you're in the ballpark, wouldn't it? Am I? Oh, that's so. Is that right? No. But you're, I mean, it's interesting. I don't do that. I don't know either. That's fine. I guess. I'm ballpark. What do you mean? Yeah, there's still papers on. Does anyone got it? Wait. I mean, you could have been a little bit more specific, but I'm going to give you the Well, Nicole got what this person did before he got like that. I say I'm actually lying. Nicole is not close. Wow. I was just being funny.
I like my answer.
Get it again. Can you go over everybody's answer? Yeah. Just talking about it. I'm not embarrassed about it. I'm sorry, my first couple guesses were about that. But the thing about your answer, okay, your answer, if you think about it, how many of those do you know outside of your own? Would anybody else, would any others really be that famous? Like, well, I mean, it's a good guess, but like, if you think through that, like, I mean, what's Alabama? But the person who was, oh, yeah. But this person is much more encompassing. Are you done, Aaron? What, did you get the bonus? You robbed the bank. Someone might maybe make that claim. That's an important. John Roberts is the Chief Justice of the United States Supreme Court. Gavin, what did you get? Gavin said governor, which, I mean, you're at least in the government ballpark, right? But and before he got that job, he did tame exotic animals, lions and tigers, I believe, and iguanas. But if you think about Gavin, your answer, like, who in here knows the governor of Alabama? But I mean, the Chief Justice of the United States Supreme Court. Alabama before the 2020 election, they did have another senator, and I had no idea how it happened. So, the one red. All right, well, our governor is the one, yeah. And I read an article yesterday that, you guys remember Dr. Amy? Dr. who? Dr. Amy. Oh, yeah. Back in the spring, she was always on TV. There's rumors circulating that she's going to run for the Senate and be a senator from Ohio. Like, because she just stepped down from her current position that she has, like her current job she just resigned from, and she's exploring something, like some sort of political. She's jumping into this political fundraising something, and the rumors are that she's going to pursue, I think it's Rob Portman, is the senator who from Ohio that has just come out and said he's not running for re-election. So, we got it. her, Amy?
Yeah.
Yeah, she quit her job as like the director of Ohio Public Health. Yeah.
Yeah, she thinks that's what her family was. He's got one lady that, you know,
I don't know her name, but she was famous.
she was the show. If you don't know her name,
Like,
really that famous.
I mean, I think there were Saturday Night Live skits about her, actually. Okay, so here's the deal. I want to do 3 more examples with you today on some of these intervals of trig powers. And, you know, I can't do an example of every single one of these that you're going to encounter. We do these examples to sort of like create a bank of strategies on how to attack these babies. Now these examples that we're going to do, in fact, all of these powers of trig functions, they all rely heavily on knowing the trig identity. Okay, knowing the trig identity. So I'm going to run through some trig identities that you might have learned last year. Well, I know you learned last year, but you may have since forgotten. Sine of 2x. Maybe you learned the sine of 2 theta, same deal. Sine 2x is 2 sine x cosine x. Cosine of 2x actually equals 3 different things. Cosine squared minus sine squared, 1 minus 2 sine squared, and 2 cosine squared minus 1. Those are also written over there. Okay? Cosine of 2x equals 3 different things. And then one more of the Pythagorean identities, 1 plus tangent squared, we said this yesterday, equals secant squared. Okay? So now we're going to do some examples. Now I'm pretty sure in this class, we did sine squared the other day. Didn't we? Okay, I think we did it the other day. Double check me on that. But I'm 85% sure we did it the other day. Like, I don't think we did it in third period, but I thought we did it in here. Yeah, we did. Okay? We're going to do it a different way. All right? Different than the way we did it the other day. The way we did it the other day was integrating by parts. Okay? This way we're going to do it a different way. And sometimes there's more than one way to do something. Go figure. Okay? So what I'm going to do is I'm going to rename that sine squared using the trig identity. And I'm going to take this right here, cosine of 2x equals 1 minus 2 sine squared. And I'm going to solve that for sine squared. What do you get if you solve this right here for sine squared? Go ahead and do that. That's true. So now, over here in this integral, I'm going to replace sine squared with 1/2 times 1 minus cosine of 2x. Why was that helpful? You should be thinking about, why did we do that? Why is that helpful? If you're not thinking about that sort of thing, then you're not fully in the game. Why is that helpful, Billy? Why is that helpful? You're not rid of that power. Power sucks. We don't want those. Okay, so now we can just straight do this, man. Pull the 1/2 out. And now you're looking at this. What's the antiderivative of 1? X. What's the antiderivative of cosine of 2x? Can we do it in our head? Hopefully we can. If not, we have to do a little u sub off to the side. Okay? Is it negative or positive? Now, part of that's going to be how you're recognizing this negative. I'm pretending that negative is not there right now. So it's the antiderivative of cosine of 2x is sine of 2x over 2. So that's going to be negative because of that. Plus chips. Okay? Now, if you go back and look, whoa, if you go back and look at your answer that we got the other day, we didn't get that answer. Okay? And the reason we didn't get that answer is because we didn't have that identity with sine of 2x and cosine of 2x involved. If I take this sine of 2x right here and replace it with 2 sine x cosine x, that answer right there is going to turn into the answer that we got. Okay? Everybody see that? Question? You want to do another one? Secant cube of x and now secant and tangent go together like these and carrots. Because what's the derivative of tangent? Secant squared. What's the derivative of secant? Secant x tangent. What? You know this? There's also a trig identity that relates secant and tangent. 1 plus tangent squared is secant squared. So man, it seems like we've got to be able to make use of all this in some way, shape, or form. Now, as it is right now, if I'm going to do this with a substitution, okay, as it is right now, if I'm going to do this with a substitution, I cannot let u equal tangent of x. Why? What's the problem with letting u equal tangent? Samuel, what do you think?
We still have secant x left.
You're going to have an extra factor of c. Because the du is secant squared. Okay, so let's reverse that. Can I let u equal secant?
Now we're going to get 2 tangents of x.
Got 2 tangents left. Okay, so as it's looking right now, I can't let this u straight up tangent or straight up secant. Could we maybe rewrite this? Could I say, what if I call this secant squared times secant? And I call this tangent squared times tangent. Could I do that? And then could I say, that's secant squared times tangent squared times secant tangent. Now, who's hanging out down there in the end? Speaking of Matthias, where is Matthias? Isn't Matthias not sitting there? What? So, what's that secant tangent hanging on the end? What could he be? He could be a du. If he's a du, who is his u? Secant. Oh, crap. We don't have secant everything, do we? So the question is can you put that all in terms of secant so that that could be your u? You sure can. Tangent squared, kiddos, is AKA secant squared minus 1. So now u is secant. Du is secant tangent. Dx. Woo! So that's secant squared u squared times u squared minus 1 du. And what is that? What do we got to do in order to finish that out? Distribute. Right? We got to distribute. U to 4 minus u squared. You always got to keep those algebra pants on. That's u to the 5th over 5 minus u cubed over 3. So that's secant to the 5th over 5 minus secant to the 3rd over 3 plus the cube. Is it possible that you could have put this all in terms of tangents? And let u equal tangent? You wouldn't have an extra secant squared effect or placed in top of it. You wouldn't have that. You wouldn't have the even power of secant. So it seems like when secant and tangent are kind of commingling together like that, if you're going to let u equal tangent, you need an even power of secant. Yeah. Well, you really like that integration by parts. So yes, that one yesterday, you like. It's because it's on the tip of your, it's what we just learned. Could you do this by integration by parts? Possibly. Yeah. I can tell you, even if you did this by parts, you're still gonna get attacked by the trigger, didn't you?
I was thinking through it earlier. I think that what the one that would become out.
I mean, part of doing this by parts, you got to let u equal something you can differentiate easily, right? And dv equals something you can anti-differentiate easily. Well, the problem with parts here is when I start to rewrite this, like the u, when you let's say you just chose u as secant cubed and dv is tangent cubed. Well, you don't know the antiderivative of that, so you can't do that. So let's say you borrow one of those secants and you say, okay, u is going to be secant tangent cubed and dv is secant squared, right? You do that. Well, the problem with that is the u is so complex. I mean, you don't want to be using the product rule when you're integrating by parts, like when you're calculating du. You know what I mean? Like, you don't want to be doing that. If you find yourself doing that, you probably were like, you might be making this way more difficult. Okay, let's try another one.
Another way I would do it, secant squared of x tangent cubed of x, and then secant of x has u equal to secant squared of x times tangent cubed of x.
Say that again, tangent cubed. And then your other piece is secant
of x. And then you do the derivative of.
So u is what?
It wouldn't really complicate that. U would be tangent of x.
Tangent?
Well, no. Secant square root of x, tangent of x, then you do it. It would be not an extra way of doing it, but
Well, this right here is equivalent to the original product, right?
yeah.
Okay, so if I'm going to do this by parts, if I were going to do this, I might let u equal secant of x, and dv equal secant squared x tangent cube x. Du is secant x tangent x. V, this is actually going to equal tangent to the fourth over 4. The secant squared tangent cube, that's a u substitution. So u times v, secant x tangent to the fourth x over 4 minus the integral of this times that, that's secant x tangent to the fifth x over 4. Now I'm in stuff. So I still am going to have to break out the trig identity somewhere. And I may not even be able to do this. You know, when you get to this point, you may not be able to do it. Let's try this one. Gosh, that looks so simple. That one looks so simple. Sine cube. Didn't that just go sine to the fourth over 4? Is that what it is? Isn't it just sine to the fourth over 4? No, it's not, because of the chain rule. Stupid chain rule. Okay, so kind of what's been developing here in our strategies with these powers of trigs is it's nice if you get two trig functions involved that go together. Sine and cosine go together. Tangent, secant squared go together. Tangent, secant go together. So can you put this all in terms of one trig function and then have the other trig function just hanging out there as the du? Well, I just looked at Gary's paper. Gary did this. Genius. Well, not secant. That's genius. What does that do for her? Do you know what it does for you? Oh, yeah. You change sine squared to 1 minus cosine squared. And now what are we going to do there? You sub. Is that how they shoot a basketball game? Right? Don't they do that? You sub. You sub. Well, what do they chant? I think they chant you sub. Well, that's not appropriate. U is cosine? What's du? Negative, negative. So what's our final answer here in terms of u? Oh, look at you distributing in the negative. Smarty pants. U minus u cubed over 3. Me to distribute the negative and give it to me that way. I'll go back and put your starter in. Okay, we gotta practice, kids. When this is all over, friends, you will have done more integrals in your life than you ever thought you would. Okay? We gotta practice this. Because when we go to take the test on this, right? When we go to take the test on this, like, you're just gonna get like 10 or 12 different problems.
What is that thing?
Oh. Spray up, don't spray it at the person.
What isn't that fancy?
By a lot.
I'll tell you what, Mr. Miller, you're high tech.
Yeah, we're stepping up. I saw Emily Brazil had one,
Oh, really?
and then Colette bought one. And I was like, that's awesome. And then when we're done with all this, my wife will use that at home. Like, she sprays plants and stuff.
There you go.
Of course, it's got quite a lot of it.
Yeah, right. It's funny.
Is that at my,
All right. Have a good
But
one.
yeah, so, you're gonna get a test over this, and you're gonna get like 12 or so problems, and it's gonna be random, you just have to know how to do all of them. Okay, so you gotta stay on top. But have a fantastic weekend. The problems that I want you to start working on for this are in Google, on the Google. I'll see you. Stay warm.
have a great weekend.
You have a great weekend. I'll see you in a few hours. I did. She hasn't made the schedule for the fall yet, but she said she'll have it in, what did she say? I'll tell you. She said she'll have it in early March. Yeah, but we can schedule you, but that's plenty of time. So, early March is fine.
So if I just, I take the program, and then,
We'll schedule it like you're gonna take Calc2 here,
so yeah.
and then we'll go from there. Wait, I didn't sanitize. Don't put food on your desk. This is. No, I have to step away. I don't want you to get violent.
I have work, they have this like a thing, and it's like,
That's like, you know. Did I not get that one? That's great. We're clean in here.
Joe.
I'll stop carrying this around.
Oh, windows aren't open. Seven? It is 28. hat? No.
I love that. You turn my hair on.
No.
Yeah, you know what?
I have it coming to my left side. You can't wipe it off.
I'm not getting my butt bleached. No, my dad got his butt bleached at work. He's just there. Oh, baby. Yeah, I mean, not one day. Maybe like never.
You should shave.
No.
Also, I'm kind of glad I didn't go. Yes, this was long. Yeah. My legs are oddly smooth. So weird.
No, and the fact that it's freezing outside.
Oh, yeah.
I've not.
I went right off. And then I'll probably do it before I leave.
I never have any problems. Warm hair. When I was so dry. In case you like, I'm like, my hands are cracked. I'm always like that. It's bad. My arms, I would never put lotion on. I hate it. I hate lotion.
Well, I love
I
lotion.
hate it.
How do you hate lotion? I
It's
love
so
lotion.
gross. I hate lotion.
I love lotion.
No, it's awful.
Makes my skin feel
Lotion
good.
and stuff. And then when you like get touches on after.
Oh, hey, that sucks.
I was like, wipe my hands with a towel.
Yeah, I do that, and then it's like, why did I put lotion on? I'm gonna wipe it off.
No, I put,
No, like if I put it onto my hand, it's like, no one's going to.
your mom gonna put lotion.
Well, I don't put it on my palm, I put it on my knuckles.
Yeah, I can do it on the back.
So bad. Look at
No, I
my
don't
knuckles.
No.
Dude, some of this corn is grody. It's gonna pass right through me.
There's a lot of peanut butter on this.
Oh,
That's how you make the DJ.
I'm
More
not
peanut,
complaining, but
how do you,
there's a lot.
what's your peanut butter to jelly ratio, the ideal peanut butter to jelly ratio?
like 1.5 to 1. I don't like a whole bunch of peanut butter. I mean, not on.
Wait, 1.5 to 1,
So
which
like,
one? That's the peanut butter.
it's like a medium layer on each, medium layer of peanut butter on each piece of bread,
And
and
then,
then some, like, a good amount of jelly.
oh, that's gross.
But not a big giant pound of peanut butter on one side of the bread, like this.
Yeah, I do a lot less jelly than I do peanut butter. I do like
I don't like having
thin layer jelly, and then just a good amount. What?
What?
Peanut butter is great.
I ate so much peanut butter. I would die.
I do like a 3/4 and 1/4. 3/4 peanut butter, 1/4
What?
jelly.
That is so much.
No, it's
That
not.
is God. Isn't that 3 to 1? That's like hateful. I mean, at my house, like, I really have no business. What about you, Minter?
Yeah, Mary, what's your,
peanut butter and jelly ratio? His is 3 to 1. That's crazy.
what do you mean? Peanut butter to jelly?
Yeah.
That's so much.
Ooh.
I'm like 1.5 to 1.
Peanut butter to jelly or jelly to peanut butter? Peanut butter to jelly.
Obviously, why the heck would you have jelly first? That's the
No, you do not put jelly first. One for one.
I think that's
No, that's
No,
wrong.
that's too much.
And it might even be like 1.2 to 1.4.
Can you have almond stuff?
Because I might,
Almond butter? I've had almond butter, but I don't like it.
yeah, almond butter.
I have peanut butter right now, actually.
Butter's good.
What?
I have a peanut butter sandwich right now, peanut butter and honey,
Nice. That's good.
and a much larger bag of chips today. Because we were out of the little plastic thingies.
I don't know where all those are.
Yeah, I don't either.
I had my lunch last night. Did they remove it?
Yeah, I don't know where they are either. I think Kate's stealing them.
Hey, keep them in her room. Oh.
I like a lot of jelly. I'm not gonna lie.
Yeah, you gotta have a good amount of jelly, but a little bit more peanut butter.
absolutely.
The little thin layer of jelly, and then the peanut butter. Good. You know, 3 centimeters.
There can't be too much jelly. And make the bread sauce overpowered. But there can't be too much jelly, like, can't get the jelly at all in one.
I feel like there's too much peanut butter, but there is such thing as too much jelly, so that's why I go with more peanut butter.
I think that there's definitely a thing.
And I also think it depends on the type of jelly and the type of peanut butter. This is not a universal ratio.
You were so, yeah, but there's only one type of peanut butter, one type
Well,
of
there's
jelly.
crunchy and.
No, what? Crunchy peanut butter is not peanut butter. That's a jelly.
Crunchy peanut butter is not bad. It's just that extra
Yeah, but you
blob
don't
and
put
sugar.
it on a
Okay, are we talking all natural peanut butter? 'Cause-
Okay, so I can Kroger brand, giant jug of peanut butter.
No, that's trash.
The Jif, I was trying to, yeah.
We're talking about Jif peanut butter.
Yeah, Jif original, not reduced fat or anything like that. Jif original.
I only go all natural. If you're talking like the Kroger jug, then it's 0 to 2.
You rather just have some jelly and bread.
That's pretty nasty.
You just want a 101.3 instead of bread.
What? Ian just went a 101.3.
Yeah, last night he got second in prelims in the 500. He went a 450. Last night. He gained in finals though. He went a 451 and got fifth.
What is this his like conference championship?
Yeah.
No, they're qualifying for nationals. I think. But I know the NAIA conference canceled their nationals.
Are they doing well, are they doing no yards instead of meters? Okay, can you say,
He swims for a college that's in Mishawaka, Indiana.
Let me look. Yeah, they're gone.
3 yards?
No, or we do the drop thing. You get like a 452.
Yeah, college is yards. Short course yards.
I can't handle it. I don't mind it. No, actually, I'm not
I
anybody
can't remember which one's which.
reasonable,
Which
but
one's
no.
shorter, which one's 5 yards?
Garbage quarter.
Well, did you just ask which is what they?
He's disappointed in you.
Which is it then?
Wait, what? I'm just confused. as to-
So Marie Dawkins, that lady that came in.
Wait, Maria's here?
No, her mom is here in the building. She is second in her class at West Point. So she got second pick. Like when all these seniors get to pick what they're gonna do, she got to pick second.
Oh, was that where this was like last night? Maybe this was like last night too.
She picked Hawaii. Italy.
That's so nice. Lucky. I don't want to go. They do it by rain. Imagine being last.
You get a soda.
You're picking cleaning toilets at Wright Pat Bearson.
Yeah. Like they can they pass like a basket around lunch or whatever. People just put money in there.
It's like a pig fund.
It goes to the person that gets last.
Seriously?
Yeah.
Everyone just goes up and
You would work.
just do the worst one of things, you don't get money.
That's how they already
You go to Milwaukee.
No, but that's like the most stressful thing ever. You go too low, you get kicked out.
So I've decided that we're gonna go to Europe and visit Marie.
Mrs. Dawkins was my third grade teacher.
Oh, really?
And then my 8th grade math teacher.
So Marie was probably like in high school then.
Yeah,
Or
I
maybe-
heard all about her application process. Oh. That's when,
Second in her
she was
class.
a long-term son. I don't know, did you have SEL? I was this in 8th grade for me.
Probably not.
It was like this was like social emotional learning class. And we were oh my gosh, no.
I am
can't
so
do it.
sorry.
Literally can't
I
do it.
am
And
so
like,
sorry.
I didn't study. She like went MIA in October. That's in our class.
No, this is the original.
Rachel, you're pronouncing it wrong. Dingalinger.
Shut up. No, you guys got big break. Oh my gosh. Anyway, so he just disappeared, and then we had a lot of stuff for like 9 months. I saw that name.
Yeah, you're great.
The gym teacher?
Yes.
Where did she go?
Yeah.
She has what?
She has a kid in Billy Street. Yeah.
Yeah.
His name's Braden.
I'm not 100% sure that's her kid.
I don't know.
I mean, she had a kid that,
I'm pretty sure he is.
she had a kid that went here and wrestled that is like,
That's
27.
He wrestles right now.
what?
He wrestles now.
No.
He's doing a wrestle. She has her son that's a police officer, like, did the help in the.
Yeah, her son was like involved in the shooting in the Oregon district.
Yeah, but she has another one. I thought. I'm pretty sure Braden's her.
She seems pretty old to have a kid that's in high school.
Yeah.
I don't know. I forget.
I mean, I don't know her, but I think she only had one kid. Maybe oh my God, yeah. I don't know who she is.
Let's all be honest, really?
Yeah.
No, because she talked like for the entirety of the class period once about wasting time. Like,
My coach did that the other day.
She used to teach here.
really? Mr. Matthews is
Years
so much
ago.
better. He just got straight to doing stuff. He didn't care at all.
I'm gonna find out if that's her kid. I mean, that's not an uncommon name, but it's not a common name either.
Okay,
It's one of those middle names,
I mean, it's not like Smith.
so it's not.
Did anyone else when they were younger, like, plan out how they would escape from the house if they murdered about it? Yes.
What?
Thank you. You didn't do
No.
it. I get it.
Yeah. That is tough to follow, like,